Right, welcome back Math 9. Today we are starting our new unit. In this booklet, the unit name is Linear Relationship. So we are going to learn about a bunch of graph. Now, the thing is, I know it's a COVID pandemic time, and then in addition to that, we also had a printer problem for the last week of before the Christmas break. I do not have this booklet printed for you yet, but I want you to use blank pieces of paper. If you have a printer, I also posted this entire document in PDF format, and you can find it from Google Classroom. So please go there and download. Then finally, print it if you have a printer and enough of ink or cartilage or paper. As you may notice, linear relationship have few pattern going up and down is what we are going to look at. We are going to use equation 2. So there will be some remembrance about some terminologies and some example how to solve an equation and so on. Even though algebraic expression, which is the lesson that we did before this booklet, we already talked about a lot of terminology. Let's do a little recalling. Writing equation. Now, ladies and gentlemen, we generally construct equation to describe patterns. Now, the patterns, like what I mentioned at the beginning, we are going to specifically go through linear pattern, the one that goes increasing or decreasing constantly, basically. Before we getting into, let's define some of the terminology and examples. Variables are the one that play such a huge role in equation because variable, first of all, is expressed using alphabets. And these are the value that you need to find the value in an equation. Just gonna let my dog outside. Come on. Sorry about that. And variable is notated by alphabet, any of those. We learned about monomial, binomial, trinomial from last unit. And at the same time, we also talk about several skills that we need, like simplification of like terms. So please have that in your mind. Variables play such a huge role. And variables are also the one that can be substituted. What I mean by that is if x is equal to 3, we can substitute that value inside. Numerical coefficient. This is the one generally notated by integer, so countable number from negative to positive. It refers a number used to multiply a variable. And obviously multiplication is such an important part. For example, if I have 5x minus 3, then our numerical coefficient is specifically referring this 5 because we are talking about 5 times x in that situation, and multiplication plays such a huge role. A constant, on the other hand, is any integer that is either added by or subtracted by. So what I mean by that is, if you look at my example above, this minus 3 technically, if I'm being specific, this 3 is a constant. This is a value that do not have variable also. No variable with it. So if you remember the previous unit, when we simplified a bunch of different terms, constant was dealt with another constant. We do not combine them both. Operation, well, we do have quite a lot of operation, but a good example is positive, negative, and multiplication, division. But positive and negative, so addition and subtraction, basically separate terms. Like 5x minus 3. 5x is one term, 3 is another term. Multiplication, we generally omit in the expression. Like 5x, we don't put 5 multiplied by x literally written. Division is notated by fraction form. So if I have a over b, that's a fancy way of saying a divided by b. These are basic recalling. Now, it is important to understand the significant difference between the algebraic expression versus algebraic equation. What's the main difference? First thing first, expression. One key thing that you need to understand is it is true for all values of x. What I mean by that is x can be substituted by any single number. Now, the common key terms that you need to understand is, in the question you see something like simplify. So think about last unit. You may remember expand the form. You also learn about factor. That's kind of like division if you remember going back. Like you have polynomial. How can I find monomial, binomial that create those? Something like that. Example can be, 8x plus 5y minus 3x minus 5. And if you remember the previous unit, these two are the like terms, so we can combine as 8 minus 3. So that's 5x plus 5y minus 5, something like that. And note the fact that x can be any value that we can substitute. It can be negative 3, positive 4. You got the idea. All right, come on. There you go. All right. On the other hand, let's talk about algebraic equation. Algebraic equation. Equation is a little different. First of all, it is only true for some value. For one or some values of x. That means if you think about common key terms in this unit, you will see something like solve an equation, something like that. That's a key term. We can solve for x is equal to something. And you also have an equal sign. For the left side and right side. So in equation, you have something on the left side, something on the right side, and you are dividing left side and right side by creating equal sign in between. An example can be like 5x minus 4 is equal to 6, something like that. If you remember from Math 7 and Math 8, and it's okay even if you don't recall, Let me show you briefly. We use opposite operation. We gotta get rid of this constant -4 first by doing +4 because negative and positive are opposite. Then you have 5x that is equal to 6 plus 4, which is 10. And 5x, 5 and x are multiplying together, so opposite of multiplication is division, divided by numerical coefficient, and 5 will be gone. And what you now have left is x is equal to 10 over 5, which is 2. So as you may notice in this equation, 2 is the only value that can be substituted inside of the left side of an algebraic equation, and that way it's the only way to make left side and right side equal together. So those two distinct differences you need to understand. Now let's do some simple example, and then hopefully I go through many different type of way of expressing the pattern, because linear equation always have a pattern, linear relationship if you will, to be precise. We're gonna describe patterns, linear relationship, using sometimes sentences, sometimes equation that plays such a huge role, sometimes graph, obviously linear graph, tables, and pictures. Like diagram, if you use or remember geometry a little bit. So let's do these class example. Luke wants to earn money this winter shoveling driveway. He will get paid $9 per an hour. And here's a little bit of steps, if you will. First step is always about identifying two different type of quantity. And these two quantity, ladies and gentlemen, if I use math term and science term, those are defined as independent variable and dependent variable. So let's define some of these terms first. So, independent variable and dependent variable. When people mention about independent variable, first of all, that means variable is changing or can change. Generally, this is the one that we use for x-axis or x values. So in terms of graph, if you think about Cartesian plane, horizontal and vertical, horizontal ones. Dependent variable is basically variable affected by the change that is happening, which is by independent variable. So for instance, if I change x value, you're changing dependent variable, which is y value. So we call y-axis or y values. So when it comes to the relationship between independent and dependent, it's always independent that affect the variable of dependent variable, not the other way. Dependent variable does not affect independent variable, even though mathematically there is a way to go backward, but we are not going to focus on that. Now, at this situation, then, it is important to first of all find out, is there any two quantity that is mentioned? Yes. The one that is mentioned in here is amount of money that is being paid. That's one of the quantity. Second quantity is basically hour, is the one that is mentioned, which is time in hour. I'm going to use HR. And the amount of paid, that's how can I say? I like to say that's income, and the unit is money. It is quite important in this unit, ladies and gentlemen, before you put any type of equation, to identify the relationship between the more than one quantity that is mentioned by the scenario. So identify that. We're not sure which one affect which until the second step. Talking about the second step, now let's think about which one play independent variable, which one play dependent variable. What I mean by that is, does the amount of money affect the hour, or does the working hour affect the income? If you look at that logical perspective, you will get to conclusion that the amount of time that you work affect the amount of income. So let's go to the next step. This entire identification step was the first step. The next step, ladies and gentlemen, is this. When you try to figure out the quantity is the independent and which is the dependent variable, we can create a sentence. This is a word way of describing a relationship. But here's what we always put. Dependent comes first, independent comes last. And then if I do this word situation, that's my second step. So let's think about what was dependent. It was money, the net income. Depends on the number of hours that, what was the character? That Luke worked. So number of hours. I believe this sentence is good enough to conclude this entire pattern as a first step. We actually don't know how the number is, but that is okay. It is important to identify which one is dependent, which one is independent, because dependent is Y, independent is X, something like that. And this can become something like title too, even though it's not exact title. Now next, we create table, ladies and gentlemen. We do not go to graph at the beginning step. Now, when it comes to table, here's what you need to know. Independent variable, I generally put it on the left side, and then dependent, I put it on the right side. So consider as an X versus Y, or X on the left, Y is on the right. Even though it's not an iron rule, but most of the time people do. And if you do it on vertically, people generally put X on the top, Y at the bottom, something like that. As you may notice, since it's independent variable, you can put any value. So look what I put. With the hours as a unit, I put number of hours 1, 2, 3, 4, 5 in a table, something like that. Obviously, you need to copy this in a table though. In a blank pieces of paper, sorry. Amount that I earned, I put it A. You can put Y too, but again, it doesn't really matter. Generally, people tend to put the initial amount earned or net income for I. That's okay. You can put whatever. Now, here's what we need to know. In previous situation, we know that Luke earned $9 per hour. That means for first hour, you earn $9. If I work 2 hours, then 9 plus 9, that's 18. Third, 27. Fourth, 36. Fifth, 45. Something like that. We know that from X to Y, it is important to understand the idea that from our left to right, it's multiplication relationship. You need to find out, is it adding, is it multiplying, is it dividing, or is it subtracting? I messed up the order, but in this case, multiplication is the one that describes this pattern, because as you may know, it is always X times by 9 that give you Y, something like that. So table gives you some clue. Once you know the pattern, even though it is important to compare left and right column, it is also important to figure out what kind of changes are happening for each row. Like if I look at my dependent variable, the dependent variable from previous one to next one, it increases by $9, and same thing that is happening for each of the columns. So that means it increases by 9. This is another pattern that you need to understand. Similarly, like what I mentioned about left and right situation, and if you also, even though I didn't put that in here, if you also compare the relationship for x, as you may notice, it's increased by 1 hour for each row. Each row. So it is important to also know this positive and positive relationship, because these two give you how stiff your graph will look like. And obviously, if you have a lot of change, your linear graph, imagine this is a graph, will go really stiff like this. If it's not much of change, it's not going to be dramatic change, it's more gradual change. Now, when you write down using expression, so if we put our expression to understand what's going on, like the one that I put in previous one, left to right, which is with your x to y, that relationship you need to know. Of course, the number of hour, I use h, and then amount that I earn as a. So first of all, h times 9. So it's 9h is my algebraic expression. Know the fact that in relation, we're not talking about expression only. We need to eventually make it into equation, which is my left side is equal to my right side. And generally left side, we put our dependent variable, in this case a. So you can say a is equal to, and then I like to say, dependent variable is equal to 9h, which is independent variable side. There you go, dependent variable side. So my equation will look like this. A is equal to 9h. We are almost done for today, so let's keep it up. Use the equation to determine how much Luke will make shoveling 11 hours in 1 week. So we now know what value to be substituted. So we are going to substitute this 11 from our equation. So if I substitute those in, a is equal to 9h was 9 times h, so 9 times 11 is what I have. So $99 is what Luke will earn. Once you make that happen, it is important to write down in a sentence, Luke will earn $99. Something like that. Number 2. Use the equation to determine, now it's backward, how many hours. So we're talking about find out our independent variable. It doesn't matter, we start from our equation first. Except $27, it's not h, it's actually a value that is given, so we just need to substitute this in. $72 is equal to 9h. And even though it takes more than one step, you need to do opposite operation. 9 and h, they're multiplying, so opposite of multiplying is dividing. And then if I rewrite this expression, h is equal to 72 divided by 9, which is 8. So know the fact that by number of hour, Luke will need to shovel, So that means I gotta make sure Luke will need to shovel. Luke will need to shovel for 8 hours to earn $72. that is what you can do. Although we didn't draw the graph today because we don't need to actually do graphing for this question set, but know the fact that it is important to go through all. And here's your to-do list. I want you to go math link, textbook page 213 to do show you know, and 217 to 218 to do 1, 2, and 4. That is today's lesson.